Hi everyone. In this video, we are going to see the speed control of a metering in, metering out, bleed off, and a sequencing circuit for a double acting cylinder. Now, for controlling the speed of the circuit, we required flow control valve. Flow control valve is nothing but FCV. It is also called a speed control valve. Allows the free flow in one direction but restricts the flow in other direction. Simply, it is said to be it is a one-way direction tool in hydraulic and pneumatic operations. So a flow control valve is used to control the speed of a piston in a cylinder, generally used in hydraulic and pneumatic circuits. Flow control valve is the most important component to control the speed of the circuits. It is both hydraulic and pneumatic circuits. In metering in circuit, this flow control valve plays a major role in metering in circuits, metering out circuits, bleed off circuits, and sequencing circuits. So let's see one by one what is all these criteria. So the first one is metering in circuit. The metering in circuit, the flow control valve is placed at the inlet of the cylinder, whereas in metering out circuit, the flow control valve is placed at the outlet of the cylinder. In metering in circuit, the rate of flow of oil going into the cylinder is controlled by flow control valve. So the flow control is placed at the inlet of the cylinder. So the oil, initially the oil is stored in the tank. So with the help of the pump, the oil is pumped and it will be transferred to the direct control valve. So here the direct control valve used is a 4x2 direct control valve. So from the direct control valve, the oil enters into the FCV, that is a flow control valve, and it will directly enters into the right side of the cylinder. So if oil enters into the right side of the cylinder, the piston will automatically moves from right side to left side direction. So during this stroke is said to be extension stroke. So during extension stroke, the working medium enters into the cylinder through flow control valve. Here the working medium is nothing but oil, because it is a hydraulic circuit. So for hydraulic circuit, the working medium is oil. So during retraction stroke, retraction stroke is nothing but a reverse stroke. So during retraction stroke, the working medium enters into the tank through direct control valve. So for the return stroke, there is no any flow control valve or check valve. It directly enters into the reservoir with the help of the direct control valve. So during retraction stroke, the pressurized oil enters into the cylinder from outlet and the piston moves from right side to left side direction. So during extension stroke, when we supply the pressurized oil through inlet port, piston moves from left to right side. This stroke is said to be extension stroke. So let's see the diagram. Here it is shown that the flow control valve and the check valve are clearly shown in this diagram. And in metering in circuit, the oil is supplied to the cylinder through flow control valve, whereas in metering out circuit, the oil returns to the reservoir through flow control valve. Okay, so there is a major difference between metering in and metering out circuit. So let's see this schematic representation of the diagram. So here in metering in circuit, the flow control valve is placed in the inlet of the cylinder, that is in metering in circuit, whereas in metering out circuit, the flow control valve is placed at the outlet of the double acting cylinder, so where the hydraulic and pneumatic operations are performed. So that is the major difference between this metering in and metering out circuit. So the placement of a flow control valve is the main criteria in both metering in and metering out circuit. So in metering in circuit, the flow control valve is placed at the inlet of the cylinder, whereas in metering out circuit, the flow control valve is placed at the outlet of the cylinder. So there is a major difference between metering in and metering out circuit. So finally, in metering and circuit, when the piston moves from a left to right direction, it is also called returning stroke. The returning line of the oil enters into check valve and goes into the reservoir. Okay, so that is a major point we need to know. So the oil enters into the cylinder through flow control valve, but during a retraction or return stroke, the oil doesn't enters into the flow control because the flow control valve is an one-way valve. So with the help of the check valve, the oil enters to the reservoir. Whereas in metering out circuit, when the piston moves from left to right direction, the oil enters into the reservoir directly with the help of DCV. So here the DCV is direct control valve. So here the 4/2 direct control valve is used in both metering in and metering out circuit. Okay, so this is the working principle of a metering out circuit. The next we'll move on to third circuit. So the first circuit is a metering in, second one is a metering out, and the third one is bleed off circuit. The bleed off circuit control circuits are found only in hydraulic systems and are normally only in those with the fixed volume pumps. So this is the important point you might need to know, all of you, that the bleed off circuit is plays a major role only in hydraulic system. So it is not possible to apply in pneumatic systems. So only hydraulic systems are possible. And there is a little or no advantage to using this type of flow control with the pressure compensated pumps. A needle valve's inlet is teed into a line going to the cylinder and its outlet is connected to tank. The circuit only works with one actuator moving at a time because all the pump flowing goes to the presently operating function. So when the direction valve shifts, all pump flow passes through it and towards the actuator. On the way to the actuator, part of the flow is bleed off to tank. So the actuator does not reach full speed. Excess flow goes to tank at low pressure. Many circuits only perform work at the end of the stroke. So this flow control system saves energy while the actuator moves to and from the work piston, yet still gives a good speed control. So this is the schematic representation of a bleed off circuit. So the other name for a bleed off circuit is said to be bypass circuit. So here the flow control valve is separately placed in a bleed off circuit. So while comparing this bleed off circuit with the metering in and the metering out circuit, this is somewhat different while comparing to metering in and the metering out circuit. So initially the oil is stored in a tank, that is a reservoir. With the help of the pump, the oil is sucked into the direct control valve. So here the direct control valve usually is a 4/2 direct control valve. So from the DCV, the oil enters into the double acting cylinder through inlet port. So the pistons will be activated and the piston moves from left to right direction. So it is said to be extension stroke. And during retraction, the piston will move from right side to left side direction. So during that stroke, the oil enters into the tank with the help of the flow controller. So that is a major difference between the first two circuit and this one circuit. That is first two is a metering in and a metering out, and this one is a bleed off circuit. So here the flow control valve is placed at a bypass region. And the fourth circuit is a sequencing circuit. So this is the schematic representation of sequencing circuit. So let's see what is the working principle of a sequencing circuit. So here the circuit is depicted in figure 10.6. That is this is the schematic representation of sequencing circuit. Here a hydraulic system in which two sequence valves are used to control the sequence of operation of two double acting cylinders. So here it is the DCV used here is a 4/3 DCV. That is a 4/3 is nothing but 4 position and 3 different ports, 4 ports and 3 different positions. So, two sequence valves are used to control the sequence of operation of two double acting cylinders. So, here in sequencing circuit, two types of, two double acting cylinders are used. Okay, when the DCV is shifted into its left envelope mode, the left cylinder extends completely and then the right cylinder extends. If the DCV is shifted into its right envelope mode, the right cylinder retracts fully followed by the left cylinder. This sequence of the cylinder operation is controlled by the sequence valves. The spring-centered position of the DCV locks both the cylinder in place. So this is the working principle of a sequencing circuit and the applications of a sequencing circuit. The best example of the circuit is the case of production operation. The left cylinder should extend in order to accomplish the job of clamping a workpiece with the help of a power vice jaw. The right cylinder extends to dive a spindle to drill a hole in workplace. So here the two working principles are carried out in a single operation. That is clamping the workpiece and drilling the hole in a workplace. After the hole has been drilled, the right cylinder retracts first and then the left one. The sequence valve installed in the circuit ensures that these operations occur in a predefined fashion. So this is the main example or the application of a sequencing circuit. So then finally we come to a conclusion that hence we have studied the metering in, metering out, bleed off and the sequencing circuits. So these are used in various production operations. They are mainly used in automation. Hope you understand the topic of metering in, metering out, bleed off and sequencing circuits. Okay, thank you. We will see in another one more video.